Okay, back with one more example of how to solve a complicated problem using rewriting. And I love this example because this is a system of equations, and the problem is solve the system. Well, this is ridiculous. This is an insane system of equations. There's all sorts of stuff going on everywhere. But one of the cool things about this, and this is where noticing and being observant and constantly have this in the back of your mind, is I noticed that both of these equations have a square root of x squared minus 15x in them. So I'm going to do a little substitution, and my substitution is going to be as follows. I'm going to say, let's define a new variable, u equals square root of x squared minus 15x. Substituting a new variable. So my two equations now become u over 2y equals 5 and 3u minus 3y equals 27. But a quick rewrite of the bottom equation, multiply both sides by 2y, technically fraction busting, but we don't usually refer to it. We just notice that u is equal to 10y. Now I can substitute this in to here, and my new problem is that 30y minus 3y equals 27, 27y equals 27, y equals 1. And that tells me that u is equal to 10. And so now I can go back up here and I can say, well, then I know that 10 is equal to the square root of x squared minus 15x. I can square both sides. 100 equals x squared minus 15x. I can subtract 100 from both sides and I get 0 equals x squared minus 15x minus 100, which is a quadratic, which you can solve. So I eliminated this complicated square root of x squared minus 15x by noticing that the same complicated thing was in both of the equations. Now, did I have to do the u substitution, as we call this? No, I didn't have to. I could have just noticed that square root of x squared minus 15x was equal to 10y and then plugged in a 10y. But the u substitution is something that you will do in more advanced mathematics, assuming that you go that far. We start talking about that a lot in calculus, especially. All right.